What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at compound interest and asset depreciation. We've only really looked at compound interest when we're talking about money, physical things, maybe like an investment or a loan. But some items really lend themselves to losing value over time, especially when upgrades in technology are involved. For example, if you tried to sell your iPhone 4 now, there's no way you're getting $900 for it, which is what you paid for back then. As new technology comes out and makes your old technology obsolete, you're not going to get as much money for that item as you move forward. So the questions that we're going to get have a fixed percentage of decrease. So like 8% per annum, compounded yearly. But because we're changing the principal every year, it becomes a compound interest question, not one of our straight line depreciations that you might have looked at before. What this means is that the biggest drop in value in physical dollars is going to happen in the first year, because that's when your item had the highest principal. For example, think about if you buy a brand new car. Some people say when you drive it off the lot, the minute you buy it, it loses 20% of value. That big drop happens at the very start. But if I was going to buy a car off you and you said, oh, it's 12 years old, and I said, oh, I'll give you $5,000, and then you said, oh, actually it's 13 years old, I wouldn't go, oh, whoa, I'm going to have to knock 20% off that. I'd go, yeah, it's an old car. I know that. The value is going to be pretty similar. So if we look at the value over time for one of these questions, the value is highest, obviously, when we buy it at the very start. It drops off very quickly and then kind of plateaus the older it gets. In these questions, you're never going to have negative value, even though that could happen. For example, like a car that's so old, you need someone to pick it up to get rid of it. But for these questions, we're ignoring real life stuff like that. And we're just saying that the value drops down the same percentage all the time, and there is going to be a plateau at some point. Luckily for us, we don't have to use a new formula. The asset depreciation is exactly the same as the compound interest formula that we've been using, but instead of gaining or an addition, we are minusing that rate because we are losing that value each year. So the questions here are pretty simple. Let's say we had a car that was worth $40,000 when you bought it brand new, and it's going to lose 13% of its value each year. How much is that worth in 8 years' time? So this is nice and simple. We've just got 40,000 bracket 1 minus 0.13 to the power of 8. All you've got to do is chuck that in your calculator and you'll get the right answer. So for this one, we've got $13,128.47. Final answer. What you do have to be careful of is that this is not the value that was lost. This is its actual salvageable value now. It's actually lost close to $27,000 worth of value, so that's a massive loss. One thing that I always tell my students when they leave year 12 is that if you take out a car loan, right, say if you bought this $40,000 and you took out a loan, you'll be paying compound interest on that loan. At the exact same time, you're losing value on your asset using this exact same compound interest formula. So that means that a loan plus depreciation of what you bought, this is definitely going to be bad times, because you can't sell your asset for the 40 grand after 8 years when you might have just paid it off. So please don't take out a massive loan straight out of high school. Get a shitbox to start off, drive it till it's ragged, and then when you've got a little bit more cash behind you, you might be able to think about upgrading. The other way that you could look at these questions is by having an end value in mind as you get started. For example, let's say that you wanted to sell this car when it was half its value. After 8 years, what would the rate of depreciation have to be in order for this to happen? Because we know we're looking for half the value, or $20,000 in this example, we can say that the answer is $20,000, and that's equal to the 40,000, 1 minus the R that we're trying to find out, to the power of 8. So for this one, we've got to divide 40,000 onto the other side, and that gives us a half, because we're looking for half the value. What's left over is 1 minus R all to the power of 8. We probably don't get rid of powers of 8 all that often, but any power is just undone by the exact root opposite. So you just have to do the 8th root on both sides. This gives 0.917 blah, 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 and that's equal to 1 minus R. In this step here, I'm going to plus my R over to the other side because that's what I want by itself. And in the exact same step, I'm going to minus that 0.917 to the other side. What I'm left with is that R is equal to 0.0829, rounded of course. If I times that by 100, I get 8.3%. This makes sense. We wanted a lower rate of depreciation than what we got in the first one, which was 13%. So this absolutely checks out. Thanks so much for watching this lesson, guys. Financial maths is obviously incredibly important. My big takeaway for students as they're leaving school, Please don't take out a huge loan to get a ute that you're going to sell in like 5 years. The asset depreciation plus the compound interest loan is never a good time, and it's going to end up costing you money.